Hi guys, welcome back. This is my first video in my brand new studio. Looks very nice. It's actually my basement. I painted this wall myself. Also, you might know that I'm a little spiffier. It's because I'm kind of an internet YouTube sensation. I've been viewed over 20 times in 3 countries. That doesn't include Canada. So 3 real different countries. So, you know, I kind of want to spiff it up a little bit so when I finally make the Ellen show, I'm not embarrassed about the quality. Okay, so what I have here, we are going to be talking about half-lives today. So let me kind of get out of the scene here for a quick second. Okay, so let's say we have the half-life of chemical A is 25 days. So it takes 25 days for that chemical to decompose, or rather I should say for half of it to decompose. How long does it take to have only 5% of the initial concentration? Okay, so what a half-life essentially is how long it takes for half of the chemical to decompose or to break up. This is really important in, let's say, pharmaceuticals. You want to know how long the drug will stay in a person's body, and you measure that through half-lives. So every 25 days, half of the chemical breaks down. So after 25 days, we'll have 50% of our concentration. After another 25 days, we'll have only 25% of our concentration. Another 25 days, we'll only have 12.5%, and so on and so on and so on. Now, so that's really simple if I have a number that is either 50, 25, 12.5, 7.25, you get the gist. But 5% isn't an even half-life. So what we're going to have to do is kind of do a couple of different half-life equations, or a couple of different equations here to solve for my half-life. Really importantly, this is a first-order rate reaction, and this video will only cover half-lives in first-order rate reactions. The reason they do that is because the AP chemistry test focuses on first-order rate reaction half-lives, because the half-life is the inverse of the K constant for first-order only. So those kind of throwing a lot of information out there, but we're just going to focus on first-order half-lives today. So assume this is a first-order rate reaction. Okay, there are 2 things we have to do. There are 2 steps. All right? Step 1, we have to find K using our half-life equation. And I'll go over what the half-life equation is for a first-order rate reaction, but we have to actually find our K value. Once we find our K value, well, then it's just a simple matter of plugging K into the integrated rate law. All right, and I hope I didn't cut that off, but that last word is law. It's really important that we use the integrated rate law because we're dealing with half-life and we're dealing with time. All right, 25 days is a unit of time. So we need to use the integrated rate law because that also deals with time. If we use the differential rate law, it doesn't help us because time is not a unit in there, and therefore it's not really going to do much. Okie dokie. So my rate law equation, or I'm sorry, my half-life equation, let me just kind of put a little line there. T1/2, or the half-life, the time of the half-life, it equals ln of the number 2 over K. ln of the number 2 over K. I'm not going to get into how to derive that. There are 1,000 fantastic videos on YouTube on how to derive a half-life from the integrated rate law. Honestly, the math is a little bit beyond me, and I'm sure I would make a mistake, and then because you guys love pointing out my little errors and mistakes, I would probably get a couple of comments in class. So I'm just going to not show you how to derive that. Not really all that important. Just know that this is the half-life equation. It is not on the AP chemistry equation sheet. However, it's pretty easy to remember. ln of 2 over K. Okie dokie. So let's talk about what we have here. We know that the half-life is 25 days. Okay, I got that from my problem, that the half-life is 25 days. Well, if T1/2 is 25 days, well, I can just take this and plug this in for right here, right? And I can easily solve for my K value. Well, that's not too bad. So I'm just going to do that right here. I have 25 equals ln 2 over K, And then just a simple rearranging, I get k to equal 0.02773 days to the negative 1. Okay? So that is my, let me jump over here, that is my k value that I derived from my half-life that I can now plug into my integrated rate law. All right, so this is the k value that I found from my half-life that I can now plug into my integrated rate law. Okay, well, since this is a brand new studio, I kind of forgot to bring an eraser. So give me a second here. Let me just kind of erase this stuff by hand. It's not really the best way to do it. It looks a little clunky and there's a little bit of ghost writing on there. I'll have to clean that up before my next video. Alrighty, so there we go. Problem solved. So now that was my half-life. So if anyone was kind of freaking out that I erased that right away, you may want to go back in the video and take a look at it. But that was my half-life equation. So that was step 1. Find the k using the half-life equation. And let me just rewrite k up here, just so we don't forget it. Okay, so that was simply just taking my half-life and plugging it into the simple little half-life equation. Nothing too major, nothing too confusing, hopefully at this point. All right, please remember that the integrated rate law for a first-order rate reaction is this. Okay, so the natural log of concentration of chemical A equals the negative k times the time plus the natural log of the initial concentration, or A naught. Okay, so this is the integrated rate law. We've done a lot with integrated rate laws. You know, this shouldn't be a shocker. This shouldn't be anything new. Okay, so let me rearrange this a little bit, and let me get it to kind of a form that works out well. What I'm going to do is I'm going to take ln of A naught, and I'm going to get it on the same side as ln of A. So I'm going to take this and get it on the same side. And then, from what I'm told is some pretty fancy mathematics, this works out. Okay, so all I did was I took the ln of A, I brought it over on this side, and then apparently the ln of A minus the ln of A naught is the same as the natural log of A over A naught. If you're confused about this step, join the club. I am as well. I'm told this works. I think it's a little bit magic. But please ask Miss Vanderjack for the complete explanation, and I'm sure she would love to give it to you. Just tell her Tim Prost sent you, not me, because she scares me. Okie dokie. So, I know that the concentration of A equals 5% of my initial concentration. Okay, now I know that from my problem. I say I have 5% of the initial concentration. Well, that means that the concentration of A is 5% of the initial concentration. Well, let's just change that into numbers, because numbers always help. Whoops. So here's my A value. So here's my A value. Well, let me just plug some numbers in here. So, let me, I'm going to put it up over here, because I'm kind of running out of room a little bit down here. My board's a little bit narrower and shorter. Okay, so that means if I plug this into my value, that means I have ln of 0.05 A naught. Okay, that's A. A equals that, so I just plug that in for A. Over A naught. All right, I just left that there. Equals negative 0.02773 T. Okay, so all I did was I just took my values. I took my K value, and I plugged that in. And I took my A value, which was from my problem, and I plugged that in. Okay, so I didn't do anything fancy yet. Well, hopefully you'll see that the A naughts cancel out, and I'm left with the ln of 0.05 equals the negative 0.02773 T. And then from here, hopefully it's not too tricky, and I can do a whole bunch of math, you know, finding the natural log, dividing, it's a blast. And I can find T to equal 108 days. Okay, so T equals 108 days. So the question said, how long does it take to get to 5% of the initial concentration? The answer is 108 days. Let's take a second, let's stop, and let's think about that. So my half-life is 25 days, okay? And I need to get to 5%. So 1 half-life is 50%, 2 half-lives is 25, 3 is 12.5, 4 half-lives is 7.25, and I'm going to stop there because I don't want to divide that in half and look like an idiot. So it's going to be a little bit more than 4 half-lives. Well, if a half-life is 25 days, that means we're expecting it to be a little bit more than 4 half-lives. That's a little bit more than 100 days. 25 plus 25 plus 25 plus 25 is 100 days. My answer is a little bit more than 100 days. It's a little bit more than 4 half-lives. Makes perfect sense. Okay, now I would expect you to be able to solve a problem like this on the test. I understand that this is very confusing, especially if this is the first time that you've gone through this. But the good news is the setup is exactly the same. Every single time we find the K value using the half-life equation, and every single time we just end up plugging those numbers in. And we're able to figure out how much of a chemical is left. It's a very, very important skill and very, very necessary in chemistry. So I hope you understand. I hope you enjoy. I hope you don't have to watch the video too many times before you completely get it. Have a wonderful day, and I will see you in class. Thank you.